Okay, now 1 minute. Fine. Okay, now I will make it into a presentation mode. You just tell me whether okay. So now I will make it to a presentation mode. Okay. Now I will make it to a presentation mode. You just tell me the laser pointer. Could you see the laser pointer or not? Now it is in presentation mode. I will take a pointer now. Okay. So the pointer, I took the pointer. You just tell me, could you see the pointer? Hello? Hello?
Yes, sir.
Pointer, are you able to see the pointer?
No, sir.
Pointer is near to the glyceraldehyde, deglyceraldehyde.
No, sir. We are unable to see.
Okay, then what I will do, I will take a
Can't you take
uh,
in Zoom itself, sir?
no. Zoom. I think we don't 40 more than 45 minutes is not possible in Zoom. That is the reason I'm switching over to Google.
Okay, sir.
Okay, because more time may require, no. So joining time and all those things also takes the. Okay, now what I will do, I will take a highlighter. Okay, that means it will. Okay, now you see. I am making highlighting the glyceraldehyde. Are you able to see this highlighting?
No, sir.
Could, uh, the screen is visible or not?
Screen is visible, but we are unable to see.
Highlighter. Highlighter means maybe I will mark it as a yellow colored one. Arbitrary standard near to that. Could you see the highlighter?
No, sir.
No. Okay. What I will do, I will. So now, what is that? Uh, uh, which one? Highlighter or laser pointer? Hello.
Nothing is visible, sir.
Okay, fine. So what I will do, I will go back to the mm, non-presenting mode. Okay. I think somebody is waiting. No? Right. I think now, could you see the pointer? Means cursor.
Yes, sir.
So it is near to the glycerol. Okay, fine. So I will go like this only. So because let me see that what is the problem in visibility of pointer in presentation mode. I will try to rectify it if it is possible. So, I think you are aware about the correlation configuration of terpenoids. So, configuration means it is with respect to the diglyceraldehyde. Okay, any structure, any optically active compound. See, for example, what I will tell about the correlation configuration. So initially, diglyceraldehyde was taken as a arbitrary standard. It is not the standard of reference, but it is a arbitrary standard. So that time there was no chiral compound. So that is the reason diglyceraldehyde itself is taken as a arbitrary standard to find out the configuration. So in this diglyceraldehyde, suppose a hydroxy group is on the right hand side, then it is said to be D. So D stands for more particularly capital D. Capital D stands for the hydroxy group is on the right hand side. Then how we can correlate the diglyceraldehyde with some other compound. Suppose a diglyceraldehyde is converted to other compound without disturbing the chiral carbon atom. Okay, so chirality without disturbing the chirality. So that is the condition. So that means without disturbing the chirality, if we are changing into another form, that form will have a correlation configuration with the diglyceraldehyde. See, for example, a diglyceraldehyde which was reduced. Okay, so reduced means reduction. So what is reducing here? A carboxylic acid. Okay, a carboxylic acid is reduced to aldehyde. So that means here there is no change in the chiral carbon atom. Okay, that is the reason the obtained compound. What is the name of this compound? Okay, you just find the name of this compound. So this compound will have a correlation configuration with the diglyceraldehyde. Okay, so then the aldehydic group. Okay, so this was brominated. So where it will go, the primary hydroxy group is converted into bromo. Okay, so again this compound is also a correlation configuration with the diglyceraldehyde. What it means? It means that this is also deconfiguration, this is also a deconfiguration. And then suppose this one is reduced. I think what is called as remove conversion of uh, halo uh, haloalkanes or haloarenes to the hydrocarbon by reducing agent. Here, Br is replaced with hydrogen. Hydrocarbon is the obtained. So the what is the obtained compound is D-lactic acid. So by this set of reaction, what we can say that D-lactic acid having a correlation configuration with the diglyceraldehyde. Otherwise, this lactic acid is having a deconfiguration because it is having a correlation configuration with the diglyceraldehyde. Overall, here the principle involved is without affecting the chiral carbon. If we are changing the, if we are doing a reaction in such a way that the chiral carbon should not affect, okay, and the obtained compounds are correlation configuration with the diglyceraldehyde. If you are taking with the diglyceraldehyde, it will have a correlation configuration. Suppose if you are taking a L-glyceraldehyde, that L-glyceraldehyde will have a correlation configuration with the other one. And similarly, one more thing. Suppose if you are taking glyceraldehyde, you are converting into another form, and you are saying that that compound will have a correlation configuration with the diglyceraldehyde. Suppose if you are taking any compound, So any compound means that may be a terpenoid or amino acid, whatever it is. If that amino acid, if you are able to convert it back into a deglyceraldehyde, and that time also the compound will have a correlation configuration with the deglyceraldehyde. If we are taking a compound, if that compound is converted into a L-glyceraldehyde, what is the difference between L-glyceraldehyde and D-glyceraldehyde? Suppose this particular priority group means electronegative group. Okay, this group, if it is on the right hand side, then it is said to be D-glyceraldehyde. Suppose this group is on the left hand side, then it is L-glyceraldehyde. So throughout this correlation configuration, we will talk about only the configuration, more particularly with respect to the D and L configuration, nothing else. Okay, this is what you it's a idea about the correlation configuration. Later, a scientist called Lee Bell is experimentally proved that tartaric acid is showing a optical isomerism, and it has a two chiral carbon atoms. And later onwards, tartaric acid uh, is taken as a standard of reference. Okay, so tartaric acid is a standard of reference. Deglyceraldehyde is a arbitrary standard. And what is the demerits of deglyceraldehyde? Deglyceraldehyde is applicable for only the what is called as one chiral carbon atom containing one. Okay, so in the what is that? You can observe that. So when you are assigning a D and L configuration to the tartaric acid, it's a problematic because it contains two priority groups and it contains two chiral carbon atoms. And similarly, I think you are aware about the deconfiguration of sugars. Okay, in that cases, suppose a chiral compound is having a more than one chiral carbon atom. In such cases, the bottom chiral carbon is considered for the D and L configuration. In that case, glyceraldehyde means the bottom chiral carbon, if it is the hydroxy group is on the right hand side, then such one is called deconfiguration. So here you can say that it's a carboxylic acid. So both the side, if you are taking this carbon, this will come as a L tartaric acid. If you are taking this carbon atom, then you have to look from this side. So then also it is L only. Okay. So anyway, what I mean to say that this glyceraldehyde is a arbitrary standard. So there is no evidence for the why they are taken glyceraldehyde as a standard. Okay, that is the reason it's arbitrary. But tartaric acid is experimentally proved. Okay, so that is the reason. And a scientist called Lee Bell. Okay, he is only the involved in finding out the configuration. Okay, parameters of tartaric acid. So from that day onwards, we are taking uh, tartaric as a tartaric acid is a standard of reference. Okay, so this is the thing you need to remember, and I think you will learn more about correlation configuration in absolute uh, what you call absolute configuration, relative configuration. All this you will maybe in paper 401, I think. Okay, you are going to learn about this. Then with this, I will go to the next slide. So here I'm taking a L-glyceraldehyde. Okay, L means hydroxy group is on the left hand side. So in this glyceraldehyde, in 2 or 3 steps, it is possible to convert into a L 2 isopropyl, 2 isopropyl succinic acid. If you want to say how this can be converted, look here, a hydroxy group. This hydroxy should be converted into a what is called as bromo. Then that bromo is treated with isopropyl magnesium bromide. Then this moiety is obtained. If you want to convert this functional group CH2OH into CH2COOH. What is the difference between this and this? One carbon dioxide is added. Then what you need to do? So you can, what is that? This OH can be converted into halogen. Then that can be treated with sodium cyanide or potassium cyanide. That sodium cyanide or potassium cyanide on hydrolysis gives carboxylic acid. So this is about the synthetic method how you can convert a L-glyceraldehyde into L2 isopropyl succinic acid. So here that is not the worry about the conversion of this into this, but here the worry about the configuration. So what you can observe here, here you can observe that a priority group is on the left hand side. That is the reason it is L configuration. And in this one, the priority in this one, the priority group is on the left hand side. Here, the priority group is the isopropyl group. That is the reason it is L configuration. And one more word also you can say that L-glyceraldehyde is having correlation configuration with the L2 isopropyl succinic acid. So in other way also you can say that L2 isopropyl succinic acid, it is having correlation configuration with the L-glyceraldehyde. Suppose this L-glyceraldehyde is converted into a L-methyl. So this should be methyl. Okay. So this is not hydroxy. Okay. Maybe I can. So not. I have to take it into 1 minute. I will take it into a presentation mode. Okay. Uh, so this is methyl group. Okay. And here the methyl group is what is called as it is in the left hand side. And this methyl group is having a L-methyl. Okay. Of course, it can be 2-methyl also. L2-methyl succinic acid. Succinic acid. Oh, okay. So succinic acid means this should be a CO2H. Okay, then only it is a succinic acid. Okay, so this also I have to change it. Okay, so this is also a CO2H. So then it is a L succinic acid. So L methyl succinic acid is having a correlation configuration with the L glyceraldehyde. Okay, that means it is possible to convert L-glyceraldehyde into L-methyl succinic acid. How one can convert? You know that this can be brominated. Here bromination, here bromination. After the bromination, in the first step, it is a one equivalent of what is called as methyl. I think you are aware about the name reaction. Okay, so it is possible to change halide with another alkyl halide. No, what is that? Maybe what we can say that. So this is the primary hydroxy group, and this will be the secondary hydroxy group. So secondary hydroxy group can be easily it will okay, whereas the primary one taking uh, drastic condition. So that means this can be easily treated with Grignard reagent, okay, methyl magnesium bromide, and converted into COOH as usual in this case. That means halogenation, and that obtained one is treated with sodium cyanide and then hydrolysis. So this is how you can convert. So by involving the without affecting the chiral carbon, if we are doing a reactions, if the obtained one will have a correlation configuration with the L glyceraldehyde. Okay, that's all. Then it is also possible to convert this into a L-isopropyl glutaric acid. Okay, glutaric acid means 1, 2, 3, 4. Okay, 5. 5 carbon atom, 2 carboxylic acid containing one is called glutaric acid. So here also what you need to observe, isopropyl glycerol. So this is about a few examples of correlation configuration mixture. Okay, race mixture. Okay, this is again isopropyl 1. Okay, if it is in a 50-50 percentage, the boiling point will be like this. If it is if when you are plotting a graph versus melting point and racemic percentage of you will find a graph like this. So at 50-50 only, it will show a highest okay, I think there was a what is called net in internet problem. Okay, we will continue. Okay, I will present it now. Right. Okay, so here in this you need to remember that one is 100%. That means L uh, 1, 2, 3, 4. L-succinic acid is 100% and D-succinic acid is 0%. That time it will have a show a melting point like this. So it will vary. The melting point graph you can observe like this. So at 50-50 only you will have a more melting point. Okay, that's what you can find from this graphical representation. Okay, so with this, I will go to the next slide. Right. So here I'm taking a alpha finine. Alpha finine. Right. So what you can observe that alpha finine, more particularly this carbon, is the optically active one. Okay, that means this carbon is a chiral carbon. So this alpha finine, it is possible to convert into alpha terphenyl. In this alpha terphenyl, the chiral carbon is this. Similarly, this alpha terphenyl, it is possible to convert into a limonene. Okay, how it is possible? Just by the dehydration. And from here to here, it is possible to convert in presence of H plus and limonene. In this, the chiral carbon atom is this one. Similarly, this can be converted into a carbone. Okay, here the chiral carbon atom is this. Similarly, this can be converted into this. This is the beta one, and this will be the alpha one. Okay, here chiral carbon atom is this carbon. Of course, this carbon also one more. It contains two chiral carbon atoms. So this can be converted into a menthone. Okay, and here again two chiral carbon atom. This is one, and this will be one more. What is the difference between that and this? So this is here the CO group is here, but here the CO group is to this position. Maybe the if you are numbering from this carbon 1, 2, 3, 2 carbon, and this will be the 3 carbon, more particularly menthol. So then from here to here, what is the changes? There is a formation of double bond. So that means there is no chiral carbon atom is this one. This is the only the chiral carbon atom. So from here, from this two, it is possible to convert into a citronellal. Okay, this is also a naturally occurring compound. How? Maybe the breaking of this bond, then this will be converted into CHO. How it is possible? Maybe you can observe that CO is on reduction gives OH, and then dehydration forming a double bond. So that double bond is when it is treated with KOH, it is possible to get a compound like this. So then what is that? So again, this can be oxidized. Okay, so that means that time there will be a breakage here. So what it means, this carbon is gets converted, this carbon initially gets converted into carboxylic acid, later this carbon is gets converted into carboxylic acid. So similarly this also okay. So what I'm saying at this moment, this methyl group is this, and hydrogen is this, and then CH2 COOH is this, and then one more COOH, this carbon also COOH. So this is about what is called as and what you D methyl succinic acid. What it means? It means that here alpha terphenyl is converted into several intermediate. Later on, this that was converted into methyl succinic acid. So previously we proved that the methyl succinic acid is having a D configuration, isn't it? So so that is the reason it indicates that alpha pinene is having a D configuration. Alpha terphenyl is having D configuration. Limonene is having D configuration. Okay, menthone is having D configuration. This is a correlative configuration. More particularly, we can use one more word also. It is a relative configuration. It's not a absolute configuration. Absolute configuration is different. Okay, uh, uh, right. So with this, I will go to the next slide. So next slide, I'm taking a menthone. So menthone is converted into uh, polygon, and here what you can observe, this is the chiral carbon atom. Of course, here also a chiral carbon atom. So later on, what is the difference between these two? Here there is a double bond, here there is no double bond. Okay, that means reduction of double bond. And later on, it is also possible in one step menthone, it is possible to convert into a isopropyl succinic acid. So here, what is the priority group? Definitely, what is called as right. Okay, isopropyl. Okay, isopropyl group will be is in the uh, uh, right hand side. Then of course this can be write it as a Fisher projection formula, and we can say that it is a D configuration. What it means? It means that menthone is having a D configuration. So polygon also it's having a D configuration, and menthanone, okay, it's also a D configuration. So what is the principle overall here? The principle involved is any compound which can be converted into D configuration, so that it is said to be that compound is having D configuration. Any compound it is possible to convert into a L configuration of glyceraldehyde, then we can say that that compound is having L configuration. So L configuration and L glyceraldehyde and D glyceraldehyde is having a correlation configuration with the isopropyl succinic acid, isopropyl glutaric acid, and lactic acid. That means if we are converting any compound into lactic acid or succinic acid or glutaric acid, then we can say that that will have a correlation configuration. Okay, so this is the principle would involved in correlation configuration of terpenoids. Not only terpenoids, you can take any other compounds also. So the principle is same. So then with this, I will go to the next slide. So next I'm taking a alpha phenine. This is the one. Alpha phenine, when it is uh, converted into more particularly how it is possible to, this is okay, double bond, so this double bond, when it is treated with uh, maybe uh, that what is called as hydroboration. Okay, so on hydroboration it is possible to convert into a borneol. This is a borneol, and this one is a camphor. Okay, so of course this camphor in one or two steps it is possible to convert into a isopropyl glutaric acid, and this will have a deconfiguration. And we proved that isopropyl D-glutaric acid is having correlation configuration with the D-glyceraldehyde. So that is the reason alpha phenine is having a D configuration. Camphor is having a D configuration. That is what that is about the correlation configuration of alpha phenine and camphor. So with this, I will go to the next slide. Yes. So this is about correlation configuration. Now tell me, do you have any doubt in the correlation configuration? Hello?
No, sir.
No. Okay. Right. That means I can go to the next topic now. So next topic is about the structural elucidation. Okay, so because I so there are what is called as alpha phenine structural elucidation, campine structural elucidation, caryophyllene structural elucidation, santonin structural elucidation, abiatic structural elucidation. So these are nearly 5 structural elucidation. I have to do it, and then afterwards I have to go for a carotenoids. Okay, what I will do, I will just explain how one can go for a structural elucidation. Okay, I will take this one. So I think in maybe in 18th and 19th century. So suppose if you want to say that a compound is having a carboxylic mm, uh, functional group. So one should do a test for carboxylic acid. So what is the test? The test may be a qualitative test or maybe a quantitative test. Qualitative test means treating with bicarbonate. If there is a effervescence, one can say that it is having a acidic carboxylic acid functional group. So once there is a presence, then one should go for a confirmatory test. Then after, okay, that means there will be several experiments are involved in olden days to find out the structure. That's what I mean to say that. But today it is not the case of olden days, because today we have a sophisticated instruments to characterize the compound. Okay, so that is the reason in olden days, based on the experiment. So experiment means not maybe the one, several experiments. Okay, indication, presence, and then confirmation. Okay, so that is the reason in olden days used to take many years to do a structural elucidation. So, so with this background, maybe if I am taking structural elucidation, because I may not complete, it will, it may take more time. Okay, so that means, and one more thing, I'm also planning to take a class for juniors. Maybe what I will do, uh, uh, um, on Thursday and Friday. So approximately 45 minutes class I will take, whereas in the other days, so that means Monday, Tuesday, Wednesday, and Saturday, I will take more than an hour. Okay, that's what my plan. Okay, so then, okay, so structural elucidation of alpha pinene. So you know that the structure of alpha pinene, because we are in 2021, isn't it? But in the year 1884 and 1898, so in this year, scientists called Walhach and Wagner, so both the scientists were worked on the structural elucidation of alpha pinene. So that time they are not aware about the structure of alpha pinene, and they have come to the conclusion with the set of experiment. So that set of experiment we will discuss one by one. So what you need to assume, that you should assume that based on the experiments they okay, I think you know that once the alpha pinene compound is isolated from the uh, pinene tree, it is found that it is a colorless liquid and having a boiling point around 150 degree centigrade. Then afterwards, if they are checking for the optical activity, it is found that positive plus param 1 and minus param 1. What it indicates, the plus param means it's a dextrorotatory, minus param means it's a levorotatory. And optical rotation is a experimental phenomena. Of course, boiling point also experimental one. uh, uh, Colorless, and this is a physical parameter. Then afterwards, the obtained colorless liquid, the one is having 150 degree centigrade boiling point one. Then I think are you aware about how one can do the boiling point? Okay, distillation. Using the distillation method, one can find out the boiling point. So then it okay, plus and minus form, it is a optical activity. Okay, optical activity means this the obtained compound colorless liquid is there, no, that one when it is passed that solution, when a plane polarized light is passed through the alpha finin, it will rotate in dextrorotatory, and also it will rotate in levorotatory. What it means, if it is a mixture 50-50, then it won't rotate. Okay, uh, then if there is a more percentage or less percentage, it can go plus or minus form. And then molecular formula, how one can, I think you are aware about the after doing a CHN analysis, after doing a CHN analysis, one can come for a empirical formula. Using that empirical formula, one can convert into a molecular formula. I think you are aware about that, how to convert how to use the what is that CHN analysis to find out the empirical formula. And also you know that how to convert empirical formula into a molecular formula. And here, so what it indicates, that C10H16, what it indicates, so it indicates that, I think normally alkane means, what is alkane? Alkane means it's a, what is the general formula of alkane? General formula of alkane is CnH2n plus 2. Okay. So the based on that, it indicates that this is a unsaturated. Unsaturated means maybe the double bond or maybe a bicyclic compound. So if you want to find out the unsaturation, there is a formula called unsaturation index, that is equal to C minus H by 2 plus N by 2 plus 1. So this is the general formula to find out the unsaturation. So C means how many carbon atoms is there, you have to put here, and then how many hydrogens are there, you need to so in this 16 are there, you have to replace the hydrogen with 16. How many nitrogen? There is no nitrogen, that is the reason 0 by 2 plus 1. So that will give you 3. 3 is the unsaturation index for this molecular formula or for this alpha finin. So what it indicates that, and one more formula is there for the bicyclic compound. The general formula for the bicyclic compound is Cn H2n minus 2. Minus 2 is the bicyclic. Tricyclic means again formula changes. Okay. So then what it indicates, this supposed to be bicyclic compound. Then what is the difference between C10H18 and C10H16? Two difference. The two may be, it may contain one double bond. So that is how scientists used to come for a conclusion based on a set of parameters. Okay, that set of parameter we are discussing now. So this is about the initiation. Okay, maybe what I will do, since I am scheduled for a junior class, I will stop at this stage, and maybe I will continue in my next class about the structural elucidation of pinene. Okay, no?
Yes, sir.
Okay, so with this, I will, uh, okay, okay, maybe all you can log out. I will stop